Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of planes using the Solid Edge software. Coming to the problem statement. An equilateral triangular lamina of 25 side lies with one of its edges on HP such that the lamina is inclined to HP at 60 degrees. The edge on which it rests is inclined to VP at 60 degrees. Draw the projections of the lamina. So looking at the problem statement, we can understand that a polygon, here it is triangle, and it is an equilateral triangle. That means all the sides are measuring the same. So it is 25 and it is resting on one of its edges on the HP such that the lamina is inclined to HP at 60 degrees. So this lamina is inclined to the horizontal plane at an angle of 60 degrees, and it is also inclined to VP, that is the edge on which it is resting initially is also inclined to VP at an angle of 60 degrees. So this is the problem statement given to us, and we need to draw the orthographic projection of this triangular lamina. So we will begin the solution by drawing the xy line of thickness 0.18 So first let us draw the xy line of any arbitrary length and annotate this xy and the reference planes as VP and HP. So you can just see that the reference line is annotated and the reference planes are annotated. So now we will draw the equilateral triangular lamina resting on one of its edges on the HP. So since in the top view the triangular lamina is visible completely, I will be drawing the edge of length 25 and then the other three sides of the triangle. So it should measure 25 and the angles should be 60. I'll consider this as 150 so that the total sum angle is 180 and this will be 25. So this completes the triangular lamina resting on one of its edges. So let me annotate this triangle. So this is the corner A and this is the corner B and this is the corner C. So now we will draw the projection lines of this particular triangular lamina. So we will consider the projection line of thickness 0.13 and draw the projection line. So from corner C and from corner B through the corner A. So now we are going to draw the front view of this triangular lamina. So for that, let us trim this portion of the XY line, as the front view will be on the vertical plane because the plane, that is the equilateral triangular lamina, is resting on HP. It is not at any particular distance on away from the VP or above the HP. It is on HP. So the front view will also be on the reference line. So this is the front view of the equilateral triangular lamina. Let us annotate the front view. So the corner B is visible, so B prime, and the corner A is not visible, so A prime within the bracket. And this is the corner C prime or C dash. So this is the front view of the equilateral triangular lamina ABC. So corner B dash A dash and corner C dash. So we can see that the front view of the triangular lamina will be a straight line. So now he tells that this triangular lamina is inclined to the horizontal plane at an angle of 60 degrees. So whenever it is inclined to the HP at an angle of 60 degrees, obviously, so the front view, it will be the same line which will be inclined at an angle of 60 degrees. So for that, what I'll be doing is I'll be selecting, or I'll be using the move option, and I'll select this line along with the annotations. So I'll first go select the front view of the triangular lamina along with the annotations, and then select the move option and ensure the copy is on because I want the original entity to be in the place that is here. So I'll be creating a duplicate of this entity and I'll be moving it onto the next portion of the XY line like this. So this is the option to move the entity, keeping the original entity in its place. So now we will rotate this and ensure the copy is off because I want this entire entity to be rotated. So I'll be selecting the first point of rotation as B dash A dash and the next point of rotation as C dash So I have to rotate this by an angle of 60 degrees. So I'll be entering the angle as 60 and then indicate the direction. So this is the direction in which it has to be rotated. And all the annotations pertaining to the front view shall be above the XY line. So just I'll select this annotation and move it above the XY line. So now let me draw the vertical projectors of the triangular lamina. So I'll be selecting the line option again of thickness 0.13 mm and draw the corresponding vertical projectors. So this is how I've drawn the vertical projectors. And then I'll be drawing the corresponding horizontal projectors from A, B, so that they're intersecting the vertical projectors from B and A, and next a vertical projector from C, like this. And then I'll be selecting the line of thickness 0.50 and then completing the top view of this triangular lamina when it is inclined at an angle of 60 degrees to the HP. So you can go for the angle between option. So select this view and then the reference line, so it is 60 degrees. So now we will use the trim option and trim the remaining part of the projection line which is not useful to us. So we will select the annotation text option and then we will annotate the view of this, the top view of this triangular lamina as ABC. So you can just see that the second view is almost distorted or diminished compared to the original position of the triangular lamina, because here it was lying exactly on the HP, but now it is inclined at an angle of 60 degrees to the HP, and that is why the view in the top is also diminished. It is not looking exactly the dimensions of that of the initial position. Now, as per the problem statement, the edge on which it is resting, that is AB, is inclined to this vertical plane at an angle of 60 degrees. So now let us draw a line of arbitrary length having an angle of 60 degrees with respect to the vertical plane. So select any arbitrary point on the reference line and draw a line of any arbitrary length, but the angle should be measuring 60 degrees. So now we can just go measure the angle. So select this line and the reference line, and the angle is 60 degrees. So now I'll be selecting the second view or the distorted view of the triangular lamina along with the annotations, and then select the move option again. So ensure the copy is on. So this light blue color indicates the copy is on and the original entity is going to remain as it is. So now I'll be selecting this triangular lamina from the point A and place this point A on the 60-degree line like this. And now I'll be selecting the rotate option. So this is the first point of rotation, the second point of rotation, and I'm going to place this edge AB on the 60-degree line. Now this is the move option. So I'll be moving. So the copy was on, so that is why the original entity is there. So this is how the copy is going to work. So select the move option. Now I'll be selecting this triangle along with the annotations and select the move option. I'm just going to drag it down a bit so that it is not. Okay, so it is a bit clearer now. So let me select the line option and select the 0.13 mm as the thickness and draw the horizontal projector from the corner C. From the corner B dash A dash, the projector will be overlapping on the XY line only, so I need not have to show it again. So let me draw the projectors from corner A, intersect the XY line because the locus of A is on the XY line. Similarly, the locus of B is also on the XY line, and hence the projector from the top view will also intersect the XY line like this. And now let me draw the projector from C and intersect it with the horizontal projector of the C, like this. So ensure all the projector lines will be 90 degrees or minus 90 degrees. So now these are the point of intersections, and now let me draw the front view of the triangular lamina. So from B, the corner A to the corner C and back to corner B. So this is the view of the triangle in the front view when it is inclined to VP on one of its resting edges. So this is the corner C dash, and this is the corner B dash, and this is the corner A dash. So we can trim this projector line which is not required to us. And now let us use the leader option to indicate the direction of the projection lines and try to place the annotations so that they're not intersected with the projection lines and they're not looking clumsy. So let us have a neat presentation of the projections. So now let us draw the indicators. Select the leader option. On the properties, select the black color of the arrowhead. So the projectors have been drawn upwards. So this is the direction. And the projectors have been drawn from left to right. So indicate the direction. And here it is drawn downwards. And here it is drawn upwards. So this completes the problem statement. To sum up, there was an equilateral triangular lamina resting on one of its edges initially, and it was also placed, or it was inclined with respect to the HP at an angle of 60 degrees. So this is the second position, and the edge on which it is resting is inclined to VP at an angle of 60 degrees. So this is the third position, and we have completed the inclination of the triangular lamina with both HP and VP as per the problem statement given to us. So this completes the problem. Thank you all for watching.